Okay, so rate of change is also a really important, much more practical application of calculus, and also really helps you to kind of see it in context of reality. So quite like this. It just makes it really, yeah, makes you kind of see it for what it is in terms of the real world. So hope that you enjoy this part of the section. What is rate of change? Okay, so basically, you know, rate of change can be applied to so many different contexts. You could be talking about a car with its kilometers per hour. You could be talking about an athlete running in meters per second. You could talk about a rocket ship. You could talk about a ball being thrown in the air. Anything that has kind of any kind of rate of change in distance and time or anything like that is going to have this kind of, we're going to be able to apply this. So in the sciences, we most commonly use rate of change, which is the concept that we apply in rate of change is what we call velocity, okay? So basically what I want you to really to understand is this. If we talk about the word velocity, okay, you need to understand that velocity is the rate of change of something, okay? Now, we've learned all the time up until now in calculus that if I'm talking about the rate of change of something at a particular point, do you agree I'm talking about the derivative, okay? So here's the connection. If you have any kind of question where they say the velocity of the rocket ship after 25 seconds, okay, what we're saying is we're looking for the rate of change at a point. So therefore you would use the derivative of the equation representing the rocket ship, and you'd work out the derivative, and then at one point, which obviously would be 25 seconds, you'd work out its rate of change. Okay, so velocity, whenever you have to use velocity, you're going to use derivative. Okay, and yeah, just make sure that it's very clear to yourself that the word velocity can kind of be interchanged for the word rate of change, can be interchanged for the word gradient. All of these represent the same thing, and all of them are basically calculated by the use of your derivative, your first derivative. Okay. Right, so this is what we've said over here on your notes. So we calculate velocity by working out the derivative of the distance with respect to the time, and it's always by your first derivative. So that word jumped down there, but there we go. It's always calculated by your first derivative. So just make a note of that for yourself, because I think I think the words can probably be more difficult than the actual understand, you know, once you work it out. But just remember, if they're wanting the velocity of something, you need to work with your first derivative. Okay, excellent. What about acceleration? So now the concept of acceleration is we're talking about the rate of change of your rate of change. Okay, so as your rate of change is going, is that rate of change increasing or decreasing, which would be represented by the acceleration, okay? So if I'm looking for the rate of change of your rate of change, well then do you agree with me what would make sense to do there is to work with your second derivative, okay? So as soon as you have to work with acceleration, you want to work with your second derivative, okay? Velocity, you're working with your first derivative, okay? Those are two really, if you can get those right, then you'll find that the application of it actually works out to be pretty easy. So bear those in mind, and we're going to have a look at a really nice example which puts it all into practice, and you should be hundreds with it. Okay, see you now.